Hello, everyone. Welcome back. And this is where we left off last class, discussing about the types of shifting, vertical shift, horizontal shift. That's what we discussed previously in part one. In part two, we are now going to be applying vertical and horizontal shrinking and stretching. And what are the two differences? So we kind of left off discussing when you have a vertical shrink or stretch, it means that you have your coefficient A outside your function f of x. If A is greater than 1, so 2, 3, 4, 5, that means it's going to stretch vertically, so we're going to be stretching it out. If the coefficient of the number in front of the function is a fraction, then it's going to shrunk. It's going to go down, shrunk vertically by a factor of A. Similarly, now if you have a horizontal shrink and stretch, look at the differences. Now, A was on the outside for vertical. If it's on the inside, it's going to be a horizontal. So if the A is on the inside, you're going to shrunk horizontally, and you're going to be stretching it out to the sides horizontally if it's a fractional. My A is a fractional value. So it's between the number 0 and A. So what we're going to be doing is looking at question number 5, and we're starting to evaluate. So first, what do we see about A? So A is on the outside of the function, and A is in between 0 and 1. It's fractional, right? So if it's a fractional and it's outside, it's going to be this scenario. So that means it's going to shrunk vertically by a factor of A. So let's start by evaluating here our value 0. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. So we're going to be graphing our x squared values. So 0, 0, 1, 1, 2, 4. And then we have 3. So let me redo that. 1, 1, 2, 4, 3, up to 9. And then we know that the 4 is going to be going over there. And we know it's symmetric. So at 3, we're going to be at 9. So we know the parabola of an x squared term with a 1 as a leading coefficient looks like this. Now, what happens if I insert the 1/4 in front of it? So it's going to be 1/4 times 0 squared, or 0, that's 0. 1/4 times 1 is 1/2, 1/4. 1/4 times 4, because that's x squared or 2 squared, that's equal to 1. And then we have 1/4 over times 9, the value, 3 squared. It's 9 over 4, or 2 and 1/4, if you want to change it as a mixed number. And then here we have 16 times, 1/4 times 16. So 1/4 times 16 is going to be equal to
600.
1/4 times 16. Sorry about that. That was my phone. Is equal to 4. So now we have the point 0, 0, 0, 1/4. 1 and 1/4. So basically I'm taking my x, my y, my x, my y, my x, my y. So 0, 0, 1, 1/4. We have 2 and 1. We have 3 and 9/4, and 4 and so we have 4 and okay, so let's go ahead and input that, and I'm going to use a color orange. Now I'm going to be using, so 0, 0, the starting point is the same. Now we have 1 and 1/4, which is something tiny right here, close to 0. And then we have 2 and 1. And then we have 3 and 2 and 1/4, like so. And then we have 4 and 4. Like this. So we know, again, we're going to have a reflection And then at 2, we're gonna have a 1. At 3, we're gonna have a 2 point. So at 3, we're gonna have a 2 and a 0.2 1/4, and then at 4, we're gonna have 4 by symmetry. So I said I was gonna draw it in color orange. So the orange graph that we see is 1/4 x squared. So basically what we did is it stretched or shrunk vertically. So it's gonna shrunk vertically because it's 1/4. Now, since g of x is also the 4 is on the outside, the 4 is on the outside, so 4 is greater than 1, so a is greater than 1. So we know this is gonna be a vertical stretch by this definition. It's gonna stretch vertically. So let's start by inputting. We already know the values of 0, 1, 4, 9, and 16. Now what happens if I multiply a 4 by those values? So 0 times 4 is equal to 0. And then we have 4 times 1 is equal to 4. And then 4 times 4. Why 4 times 4? Because we're inputting 2 squared in here. So 2 squared is 4 times 4 is 16. And then 4 times 9 is 36. And then 4 times 16, 64. Okay. So let me write that a little bit nicer. So it's nice and visible for everyone to see. So 64. Therefore, the points that I have are 0, 0, 1, 4, 2, 16, 9, 36, how it's growing very quickly. And then we have 4 and 64. So we'll begin with the black 0, 0, 1, 4 up here, 1, 4. And then 2, 16, that's like all the way up here. So that's all pretty much what it takes. Because this is going to be stretching vertically. So see how it's stretching like so? That black one is exactly 4 times x squared. So we have 3 graphs. We have the black graph, which is the parabola with the vertical stretch. We have our regular, the blue, which is the blue represents the one that doesn't have anything, where 1 is the coefficient, and then the 1/4 that's a vertical shrunk. So that's what it takes for us to kind of visualize the graphs. Now, very similar, but now what are we going to be noticing? That the A is in front, it's inside. So this A is greater than 5, it's in the inside. So we know it's going to be a horizontal what? So if it's greater, it's going to be a horizontal, it's going to shrunk horizontally by definition. And then similarly over here, the 1/5 is in between 0 and 1. It's a fraction. You don't see it, you just see divided by 5, but that's technically 1/5. And this is going to horizontally stretch. So instead of shrunk, it's going to stretch horizontal. So we're going to stretch it to the sides. And we're going to be inputting and getting to see how it looks like. So first, we're going to start evaluating. So y is equal to the square root of 0, which is 0. The square root of 1, which is 1. The square root of 5, well, that's an irrational number. But the square root of 5 is close to 2 point something, right? So if we find the square root of 5, it's roughly, if you can put that in your calculator, do a quickly approximation, 2.23. So I'll say 2.2 roughly, the square root of 6 similarly. The square root of 6, if we punch that in our calculator, 2.24. roughly 2.44, and then we have the square root of 7, which is roughly 2.6, 2.6, something like that. Now, what if I multiply that value by 5? So it's going to be the square root of 5 times 0. That's the square root of 0, which is 0. The square root of 1 times 5, which is the square root of 5, which we know it's 2.2. We're going to be doing now the square root of, here we have 5 times 5, which is the square root of 25, which is equal to 5. Here we have the square root of 6 times 5, which is the square root of 30. So the square root of 30, again, approximating what the value is. It's not a perfect root, so that's 5.4. And then lastly, the square root of 7 times 5, which is the square root of 35, which is also not a perfect root, but it's very close to 6, but it's 5.9. So then we're ready to graph our functions. Okay, so for the blue will be the regular, so 0, 0, there it is. 1, 1, there it is. 5 and 2 so 5 and 2.2. So we're gonna go 1, 2, 3, 4, 5, and then 2.2 roughly somewhere here. And then 6 and 2.4, which is gonna be very close to that one, and then 7, also very close to 3, but not reaching 3. So it's gonna have this behavior. This is the square root of x. Now we will put in the pink the new one. So 0, 0, same starting point, 1 and 2.2. And then we have 5, 5 and 5. So, oops. Doesn't let me write it. So it's 1, 2, 3, 4, 5 right here. And then we have 6, and then 5.4, and then 5.9. So it's going to be this pink. So see how it's going to shrunk horizontally? That's what it means. So you're shrinking horizontally. So you're just pushing it down like so. So because A is greater, we're going to shrunk horizontally because of that 5. So what's the difference between this and the next one that we're going to do? So we already have, again, the answers for the blue. The square root of x is 0, 1, the square root of 5, or 2.2, the square root of 6, which is 2.4, the square root of 7, which is 2.6, right? We already did that on that left side. Now, the thing is, for the new part is we have a 1/5. So it's square root of 1/5 times 0. That's still the square root of 0. Square root of 1/5 times 1. And in this case, of course, using your calculator, what is the square root of 1/5? And then that's going to give me smaller number, 0.44. And then here I have the square root of 1/5 times 1/5. That's the square root of 1 over 25. Or in this case, this is the same as 1 over 5. Because, so sorry, excuse me. So here it's going to be the square root of 5 times 1/5. That's the square root of 1, which is 1. And then here is the square root of 6 times 1/5. The square root of 6 over 5, which is, and again, I'm going in order and putting everything 1.09. So very close to 1. And then the square root of 7 times 1 over 5, the square root of 7 over 5 is roughly, again, approximating using your calculator. That's why it's so important to have your graphing calculator with you, so then you can be able to use that, 1.18. So then here, I'm gonna use a green. So the first one is 0, 0. The next one is one very close to 0.4, the other one 5. It's gonna be 1. And then when I get to 6, it's gonna be 1.09 and then 1.18. So it's going to vertically stretch. So we're stretching it. We're horizontally stretching it, not vertically. So these are the differences. So this is the square root of x over 5. This pink one was the square root of 5x. Okay, so just being able to kind of have a visual representation of what's going on when you're doing a horizontal shrink or stretch versus so see how everything is horizontally here and this one's vertically. So you can kind of see the two visuals right there. Okay. And then what we're gonna do, hopefully, the more you do your homework, you're able to kind of identify exactly what we're gonna be doing, as we move along. Okay. All right, so the next thing that we wanna do is what is going on? So we wanna use the graph that we have to actually graph f of 4x. So first, what do we notice? We know that the 4 is on the inside. It's going to be inside, so this is going to be a horizontal either shrink or stretch. And what did we learn? Because 4 is greater than 1, what does that tell me? I'm going to have shrunk horizontally, so it's going to shrunk. Now, the way that we do this is by actually using our identifying the points that we have. So the first point is 1, 2, 3, -3, -1. Let's start plotting this, -1, 1. And then we have over here, we have 4, -3. And then lastly, we have 6, 1, 2, 3. So what is going to happen? How are we going to be able to graph the next function, the 4x? Well, we know this 4x is going to be applied to the x only. So then what we have, remember, if we had -3, -1 is now going to be, so if we do f of 4 of x, we're going to now have -3 over 4 because technically it's not multiplying by a factor of 4, but if we know that the value is -3 and we have f of 4x, is this as if we're solving 4x equal -3. So we divide, and this is how we get -3/4. And again, we're only applying it to the x value. So it's as if we were solving. So then similarly, it's only going to be applied to the x coordinate. So now if we have -1, 1, it's now going to be -1 over 4. Sorry about that. Why? Again, because we're solving for the variable. We're solving for x. So again, going back up here, now we have -1 is equal to 4x. Divide both sides by 4. I'm solving for x. Now x is going to give me -1/4. So it's -1/4, 1. So we're going to keep that. So let's start plotting these points. So first is -3/2, which is close to -1 on the left, and then down 1 right here. And then for some reason, it doesn't want me to do it right here. So it's down here. That's my first point. This corresponds to -3/4, -1. And then we have -1/4, which is closer to 0, positive 1 right here. Negative 1/4 1. And then, of course, here 4, negative 3 is going to now be 1 and negative 3. Again, because it's as if we were dividing it by 4. So it's now going to be 1, negative 3. So 1, 2, 3 right here. So at the end, we are going to be graphing the points. And then here, organization, of course. So we had 4, negative 3 that converted to 1, negative 3. And then the last one is 6 and 3, but it's going to be now 6 over 4 and 3. Again, 6 is equal to 4x, divide both sides by 4. That's how they give me my x value. And that will always be the case. So if let's say your inside was 1/4 x, then you do 1/4 x equals whatever your x value is. You say your x values equal to each other and solve, pretty much. So then we have the 6 over 4. That's 1 2/4, or 1 1/2 and 3. So I'm going to do 1, negative 3, which we did. 1, negative 3, and the last one was 1 1/2, and then up 3. Like so. And then it doesn't let me do that again. 1, 2, 3, right there. So this one was 1, negative 3, and this one was 1 1/2, or 1.5, if you will, comma 3. So then I'm just going to draw this so that this is exactly the horizontal shrunk that is occurring to the graph. And I was able to do that by first calculating my x value. So negative 3, negative 1, plotting, and then again, only applying it to the x value because that's exactly what we have. And we have a 4x, so we had 4x equal negative 3, solve for x. 4x equal negative 1, solve for x. 4x equal 4, solve for x. And then 4x equals 6, solve for x. And then that's why we were able to visualize that. So please make sure that you are also understanding how to do this process. Again, feel free to come to office hours if you need any questions or assistance. Happy to support you. Okay, so we're almost done. We're just going to go ahead and finish the section by talking about applying reflections across the X and Y axis. So we talked about what happens if there's a number in front of it, but we didn't talk about what happens if it's negative. What if my coefficient is negative? What will occur? Well, if it's negative, and again, it matters a lot. If it's on the outside, the reflection will be across the x-axis. What does that mean? So for example, this is an x squared. As soon as I put a negative, and this goes, of course, here. As soon as I have a negative on the outside, it reflects across the x-axis. Okay? Now, what happens if you have it on the inside? Well, if you have it in the inside, and that should be a different color. If it's on the inside, for example, if I have the square root of negative x, so how does the positive version looks like? So we know that this looks like an arrow, but as soon as I put a negative on the outside, on the inside, I have a reflection across the y-axis. So this is the square root of a negative x. So see how there's a reflection across the y-axis instead of the x-axis? So that's exactly what we're going to be doing and covering in the last portion of this section. So we begin by having a few things. So again, if we are going to have a graph by itself that looks like this, so f of x for this one, we have the point 0, 0. We have the point, of course, 1, 1. We have the point 3, 3. And then we have the point 4, 1. So what's going to happen if there's a negative on the outside? So if there's a negative on the outside, it's going to be a reflection across the x-axis. So notice that my x values are still the same, but what actually goes down or what changes is the y value. So then my x value will stay the same, but my y value will change. So that means we're going to apply the negative to the y. Only because it's a reflection across the x. So then if we have 0, 0, well, that stays the same. If we have 1, 1, it's going to be now 1, negative 1. Because we're only applying it to the y value. If we have 3, 3, it's going to be now 3, negative 3. And of course, 4, 1 is now going to be 4 and negative 1. So let's start graphing that. So 0, 0, 1, negative 1, like so. We have 3, 3, so it's going to be 3, but now negative 3. And then 1, oh, sorry, 4 and negative 1. So now this is going to be how it looks like. This is actually a reflection across the x-axis. So see how it's now on the lower part? Now, if we want to reflect it across the y, and I'm going to use a different color. Now, it's because it's on the inside. Let me use a black. You're going to apply the negative to the x. So using the same coordinates, now 0, 0 is going to become 0, 0. We have 1, 1, but now it's going to be negative 1, 1. The other one was 3, 3, but now it's going to be negative 3, 3. And lastly, 4, 1 is now negative 4, 1. Again, because we're only going to be applying it to the x value. So let me use a green. So 0, 0. We have negative 1, 1. We have negative 3, up 3, like so. And then we have, of course, the last one, now negative 4 and 1. So then my graph will look like this. So now this is a reflection, of course, across the y-axis, and this was the x-axis. So reflection across the x, reflection across the y. So just to quickly summarize what we did today and what we did on last class was this quick summary. And just being able to identify the vertical translation shifting upward, downward, to the left, to the right, vertically stretch or shrink, horizontal stretch or shrink, and then of course reflections. And guess what? When we look at our equations, it's actually going to be a mixture of everything. So we're going to go ahead and look at the last few pieces and discuss what's going on each of them. Graph the function defined by 2 absolute value of x plus 1 minus 3, where we know that the parent function is the absolute value of x. If we look at number 1, just to be able to graph it, we begin by looking at our plus 1, which is a left. It's a horizontal shift to the left 1 unit. Then we see a subtraction. That means it's going to, and this one actually, you can, it doesn't really matter how you go, but the way that the textbooks wants to is to first look at the horizontal shift, then the vertical stretch, the outside value of 2, which is greater than 1. We know it's going to be a vertical stretch, so we're going to be stretching it out. And then lastly, the vertical shift up or down. So the -3 says you're going to go down 3 units. So just being able to detect what's going on with the function itself. So we're going to do that for the following, and this is the last piece. So what can we detect? Well, we know that the parent function, of course, is the absolute value of x. What else do we notice? Well, in this case, we have first, this can be changed as -1/2 the square root of negative x plus 3. So you actually want to be able to modify that. So here, the first thing is there is a horizontal shift to the left 3 units. So from 0, 0, we know we're going to go to the left 1, 2, 3, like so. That will be our starting point. We know that there is a 1/2 on the outside. I know that there's a negative, but before that, the 1/2 is A, where A is in between. So 1/2 is in between 0 and 1. It's a fraction, so it's a vertical shrink. So it's going to shrunk vertically. And then, of course, the negative on the outside, what does it mean? It's going to have a reflection across the x-axis. So that means that it's going to live down here somewhere. But at the same time, there's a negative on the inside that tells me there's also a reflection on the inside. By the square root of a negative x. So that means that it's also going to be either both. So in this case, what we want to do is be able to detect all these things. And the good visual for this type of problem is going to desmos.com, and I'm going to go ahead and project that. And then just being able to, and then let's see. Okay, there it is. So let me share my new screen here on Desmos. And if I want to say, okay, I want my y function, sorry about that, y equals, I'm just going to write it as it is, 1/2. And then I'm going to do SQRT, means square root of 3 minus x. So see how they took it as a reflection across the x-axis because the outside one will dominate in this matter. However, if let's say I just copied this and it would just 3 minus x. Now you'll have a reflection across there, your x, but your y will also be part of that. So if you have a regular square root of x, so see how it's now a reflection across the y because of the negative on the inside. So see how you have that? So 3 minus x. And then if I go back to our original, that in that case, what dominated was the -1/2. So compare that with y equal the square root of x, which is mama. So first we had a reflection. So we knew it was moving to that left side what they also did, you can also factor out a negative. That's what, you can also have done in here. Um, so then your graph now was here at +3. But then you have that negative that switched. So remember how we had it in at here, but that negative put it back to 3. So just making sure you do have that visual representation is definitely useful. So please make sure you have that. You can also use your graphing calculator that you have access to by all means. All right, so that is the end of this lecture. We will continue. So please make sure that you're consistent and you're looking at your notes, you're looking at our Canvas webpage. Please make sure that you're actively participating and coming into office hours if needed. All right, I will see you on the next video. Thank you. Bye-bye.